Welcome back. Sorry, I had to cut in. I was doing a video earlier. So to get into it, I'm using Wilian Silvian's AI, or excuse me, his IK control rig system for mecanim. Um, there's not that many viewers, however, uh, it's still, my favor to do something to help somebody figure something out, because I've been in the same position. But I highly recommend you guys to read through manuals, maybe. Um, not necessarily just kind of watch like when you, I don't know. It depends on how you learn, I guess, so I'll just hold off on that. So I set up a scene here, just to go through it again. We're going to go back to the inspector. So just kind of set up a scene with a plane, use your own grid texture. Everything's on 0, 0. And go ahead and create a new player or leave the one that was previously already there for test phase. It's kind of irrelevant, uh, just more preferable for you to just kind of get the grasp of what we're doing here. So um, what I did is I created an empty object, a scene, just to manage the other obstacles that are going to be inside our scene. Created a bunch of cubes, parented them under it, same with the ground. Went over here, let's get rid of that. Went over to the scene, uh, went over to our scene inspector. Sorry about my dogs. This is kind of a problem I had before. Go ahead and click static, and yes, change the children. My little chihuahuas think they're just the most ferocious thing, and there's a little baby crawling around him. They just had babies, so I got little babies running around. Ow! Jesus. Little babies that bite your fingers off. Girl, stop. Stop, please, Baba. Hey, you're okay. Okay, everybody is okay. Come here, girl. Little baby wants to. She's a mean little shit. She wants to go around and bite the other dogs. So She's going to the dog pound. That's it. She's going to junior dog care. Wasn't that horrible? Oh god. Okay, so her scene's set up. We're gonna use Unity's navigation system. If you guys want to get into it further, I highly suggest looking into the math and formulas behind A star. A star just basically is I don't know what do you use A star for. I don't know what it stands for. However, A star is basically a procedural step check. So if I were to, it's kind of one of the basic um, AIs that came out. If you ever watched Doom, there's not really a real complex, the original one, the very first one, there isn't really a complex AI, and you don't find that in most games. Pac-Man actually kind of has a star to it. It doesn't really check though in a three-dimensional trigonometry, so it's kind of hard to really say. AI has grown up a lot. Um, because we're getting into things of cost efficiency, lag efficiency, and time frames, and all that. So when you find new games, a lot of the new games have a nav mesh that gets baked. Basically, a nav mesh is just a. So, okay, if I had our character, our bad guy, let's see, our player here represents the actual bad guy instead. If I were to want to have a marker here, um, our player starts from point A to point B. However, if we were just to move towards that direction, he's just gonna, unless he has a rigid body, especially, or some kind of sliding rhythm. That's another thing is you find older games with a sliding algorithm, and it's kind of a pain in the butt. So. Uh, Needless to say, just to make it simpler, a physics emulation, uh, our baddie or like a zombie or something would just kind of slide against the walls until he gets to the point B. However, if we wanted to navigate, obviously we would go straight diagonal into here and go right over. But so in a sense, if you could draw a line to where the enemy's AI is, mathematically, that would be A star. So you can use things like trigonometry, and you use a distance in that trigonometry to test how many steps before you get there. So you can think of different ways of doing it with grids. But now we have navigation meshes. So if I had something, if this were a representation of stairs, for example, if I actually went up ahead and moved that up, it would be very complicated to use a A-star algorithm when it has a height. Although you can, but your navigation's gonna have issues. So one of them issues is if I had a ramp here or stairs that connected to this object right here, what if the enemies take damage when they fall off? You know, what if this is too high? What if he reaches this point and when he's trying to get to you, he falls off? Or even needless to say, at the small amount, why would he want to go fall off and then have to go all the way around again? So now we've gotten more into a process of wanting to build a navigation system because once I build this nav mesh, you'll note that it has a margin to where his navigation is so he doesn't fall off. Pretty simple, but highly more complicated, you know. When it comes to something like building a nav mesh, I have no clue. So anyway, happily and understandably, Unity has released its nav mesh agents and its nav mesh system and its dynamic obstacles. Which, if you're making a procedural world, it might not be the best choice. But then again, if you're making a procedural world, you know, it's not going to be too frowned upon if you don't exactly have the most complicated AI. Or highly appraised if the more complicated you make it. Alright, no said. So anyway, I just have a basic scene. What you're going to want to do though is mark every object that is going to be wanted to be avoided, or pretty much every object in the scene that's a solid or a hard surface that doesn't move. Because if I were to hit play here with my transform gizmo, my movement gizmo, you'll note that nothing is movable at all anymore. And when we mark things static, I guess it's an easier way for Unity's navigation system to say this is an easy way to locate all the objects. Since they don't move, then our nav mesh will be easy to build on top of that because you know nothing's moving. It doesn't have to rebuild. So and a navigation mesh typically isn't dynamic. Because we might be able to do at this level that we have and build it on the fly. However, if we build a massive level with an open world, for example, it has a hard possibility of doing so. So, yeah. Anyway, uh, we're gonna start off with our level. We're gonna go over here to scene. Make sure I'm just gonna go ahead and make sure everything and its children is static. And then I'm going to go ahead and go over to window navigation, and it's going to pop it over here. You can move the tab anywhere you'd like. And I kind of wanted to fix our navigation mesh, but once you bake it, you're going to end up with something like this. And all of the blue area, according to the areas, is a walkable area, and all of the purple is not a walkable area. However, when you're marking things, maybe you want this object to be not walkable. You can do that by just selecting the per object and making that not walkable if you don't want that one in particular, if you built it that way. So, anyway, yeah, so this is not a bad little scene to test out. So, we're not going to get into the actual mechanics of the IK system probably in this tutorial because it's going to be pretty lengthy. However, what we're going to want to do is create, I guess, what do we want to start with? Let's just go ahead and start with something like a cube or a sphere. No, let's start with a capsule. And I'm going to hop over back to that capsule and I'm going to reset it. Sorry, I got a flood warning going on. You can hear that buzz in the background. I live in a fucking cool zoo, man. So it's all good. Alright, so I'm going to put everything and then adjust the Y a little bit so that it's actually touching the ground. Alright, this will be, I'm going to shrink it down a little bit too. And then drop it back on the Y. I don't really like that. But... Alright, so, yay! Our capsule. We're going to go ahead and rename that object to baddie, for example. Okay, so we have our baddie. Do I have a baddie script before I start doing this? Yeah, I have a baddie behavior. Shit. I'll have to name it AI behavior or something like that. Okay. But we're starting off simple. Um, so let's make this simple. So what we're going to want to do is attach a navmesh agent to that capsule. And now besides the capsule collider, you can see that there is a navigation collider, a cylindrical navigation collider. I kind of want to build out my own colliders for the nav mesh system. I'm sure that you can change them. I don't know. Yeah, navigation, agent type sphere, that's new to me too as well. That's okay, we'll leave it as a humanoid because we're going to be using a humanoid later. Alright, so you can adjust the base offset of this capsule. Typically it's going to adjust correctly. However, you can adjust the base offset and you can adjust the radius of it. So, how far the avoidance collider actually works. Keep in mind this isn't going to be used for any damage to the actual AI itself. This is just all navigation system. And you can adjust the height too if you'd like, if something doesn't look appropriate to you. Also, you can see here in the pathfinding auto traverse off mesh link. So if by any chance this object has an error and it's outside of the navigation system, then it's going to try its best to move towards our target and then move to, once it gets back on the navigation mesh, it'll start using the A-star path finding system. So this is going to use something like I said before. It'll use a kind of like its own simpler method of navigation. So instead of the navigation mesh, auto repath, if it doesn't have a correct path, then it's going to find its own path. However, we could code a auto path every time it needs to auto repath itself. So if you don't like the way it actually navigates and travels and path finds you, then you can do it yourself. However, it does a pretty good job of itself. Area mask. What mask does this object use for itself? So if I had something that you did, something that jumped, um, and something I didn't, but I still want to use the same navigation mesh, then I'd untick jump. Alright, so we have our radius, our height. We can also change our obstacle avoidance quality. You know, if we have multitudes of objects and we were like, I just need a little bit more frames, you can turn that lower. However, keep in mind when you do obstacle avoidance at a lower quality, it's going to draw out a lower quality line if you kind of visualize it that way, or a lower quality rotation and all sorts of things. Alright, and the priority collision, I'm going to leave that at 50. That's a little bit more complicated than what I'm getting at, even though I have the gist of the idea. So that's our nav mesh agent, and this is attached to any AI object that wants to use the nav mesh. Okay, so furthermore, we're gonna move this character back a little, just to show you how easy this is. You can see his forehead's kind of hanging that way though. To give a better example, we're gonna go ahead and right click our baddie. and we're going to create a cube. And I'm just going to shrink this cube up a little bit. And I'm just going to extrude this out the forward. That way you can see the front of the object. Maybe move it up. And kind of looks like a duck. So we have our duck bill over here. Best game we'll ever create. Anyways, so yeah, we have our little AI dude, and that way we can just kind of see which direction he's rotating in and which direction he's moving in. It's just simpler that way. You don't need to add anything special to it. Actually, you can just go ahead and remove the box collider to save on memory if you'd like to do so. So, anything saves anything. Um, because technically you have 4 more vertices, and you have the triangles that attach to them. So, and you have a collider mathematical formula. Math collider thing. Alright, yeah. Alright, so we'll move him ahead. And looks pretty swell. And hit play! And nothing happens, right? We can walk over to the guy. Hey, how's it going, dude? Not so well. I can't move, so let's get him moving. Alright, so what we're gonna do is I'm gonna create in assets a whole new script folder just for this. I'm gonna call this AI tutorial. And what we're gonna do is create a new C# script. If you use Java, I've become real familiar with C# and I just tend to like it more. So, although Java has its good points like its array. Um, when you add to an array, you can add to it without having to do things more complicated. Anyway, so this is going to be our polymorphic parent class, and we're going to call this AI behavior. And the reason is, in future reference, if we have different types of objects, we want to have a structured class that takes basic things that every other enemy has, and that might be just have a health parameter or a health property, maybe a speed property, maybe a damage property that gets passed into any gun, any damage we take or add. You know, things defense. If you think RPG, it'll make a lot of sense, especially to use polymorphism. So, yeah. And then especially if we're doing things, which you'll find out later, I don't really want to get into it, but if you shoot something and you want to, you know, you can send a message that every script can have, but however, how many messages do you want to send? How many functions do you need to write to do that? You don't want to rewrite everything. So what we're going to do is go ahead and clear that out. We're going to go ahead and write a private float lowercase health, and we're going to write a public float health to expose the property, and we're going to use get set. And what we're going to do here is just basically this is our actual variable that we're modifying using the health. Um, keep in mind you don't have to do it this way. There's all sorts of different kinds of methods and structures you can use. So just kind of read maybe through C# and figure it out, because my explanation won't be good as the solid explanation. Because the way I remember it might not be a good way for you to remember it always. Alright, so all we're doing here is we're going to return this dot health and make sure that's the lowercase one, and then we're going to say this dot health equals the value. So we're just returning our health and modifying it to the public property there. And we're going to add another one, private float speed, public float speed, get set get speed, oopsie, return speed, return this dot speed. It's a good habit to say this because it means this object. Especially when you're using parroting, you would typically have to use this or that, this and like that, or something. Anyways, so this dot speed equals the value. Pretty simple. And to make this easier, we're just going to copy that set and do the same with the damage variable. And this dot damage and this dot damage. Wow, I spelled damage wrong. And that needs to be lowercase as well. Alright, there you go. So far, let's just keep that. What else do we need? We'll leave that for now. And we're going to create a new C# script. What are we going to call this? We're going to call it a seeker, even though that might be slightly incorrect. So since we're using polymorphism, we're going to go ahead and use the seeker instead of saying type of mono behavior, because over here we already have it deriving of mono behavior. In scope, we're going to say of AI behavior, so that this class inherits the AI behaviors class. So everything in here, all these public parameters are going to be inside here. We're going to go ahead and remove these functions, and we're going to create a new struct AI behavior. And seeker. So basically what a struct is it's going to use, it's just a structure of data. If that makes sense. So our main struct follows the class. It inherits our AI behaviors. So if I wanted to change the properties, like health, we can do that here. Alright. However, the only thing, I don't really want to change any of that actually. We'll just keep that there for now, just in case we need it later. Alright. So if we're going to have a seeker, I'm going to go ahead and go over to the baddie. And I'm going to go with that nav mesh, right click and remove it, the nav mesh agent. And we'll just code everything. So when we're going to be doing this, a good way to do this, if you guys are a little bit worried before we get into it, is to have like a base object with all the parameters that you like, and then add it. But the reason I want to do this is just kind of give you an idea to make things really simple and we don't have a clutter of things. I mean, there's no problem assigning an add mesh agent. I suppose we can open its properties. All depends. No, let's just stick with the easy way for now. We'll get a little bit. We'll just add component. I was about to say for every seeker we're gonna add a component of an mesh agent because it needs one. However, it might be easier just to visualize it before it starts because once we plop it into the game, we want to modify its actual collider. So bear with me here. Alrighty. So the next thing we're gonna do is we have a start function. So we're going to make this public. We're going to make this virtual. Virtual meaning that once we create another object that derives of this object, we can override a function. So if you think of the properties being overridden here in our struct, for example, it's kind of like the same thing. So when I go to do it, I'd say in the next script I'd say override. And that overrides the previous function. Anyway, public virtual initialization. No. Fine. Initial. I don't know why I want to initial. Excuse me. Every time when it comes to certain words. Really. Initialize. Initialize. I hate when the IntelliSense does something that's close. Oh, and then it's red because we don't know what we're doing. We're just going to type void for now. So this function will just initialize everything. And one of those things, I need to write a new variable here. I'm just debating whether I need to add a public variable. It doesn't matter since we're not going to be able to see this, so we won't need to use serialized fields. So we're just going to say public. Oh, excuse me in my French. Before we do this, if you're going to be scripting any Unity AI, you have to open up the library AI, or the assembly AI, or the namespace AI for that matter. And we want to do that. We don't want to always include that. So the good thing about doing this is that once we initialize this, it's basically calling into a section an initial, like kind of like a preload to what we're going to be using. It's unnecessary to use things that you don't need. So always use less or more, even though, for example, I have a generic right here, and I don't necessarily need a system collections.generic. Well, I know of yet, unless it's something new to me. Yeah. All right, so we're gonna make a new public variable here. We'll do the same. We'll make it a property. So private agent. Oh, excuse me. Nav mesh agent. It was correct there. And we're gonna say agent, and then we're gonna expose that publicly. So public nav mesh agents. Agents. Really? Why not? Alright, now we're going to do the same thing. Get, set, get, return this dot agent. Yeah, and this dot agent equals for the value. We got a semicolon up there. Okay. And what we're going to be doing is once we call this in our next child object that uses the seeker type of AI. So we're going to call this like a capsule cube or something. Who knows? Until we get there, I'll just call it a bad guy with a cube coming out of it. Yeah. So what we're going to want to do is go ahead, grab that public property, and say agent, and this is real simple, get component nav mesh agent. So we're just going to go ahead and grab our nav mesh agent. And yeah, sorry, I'm trying to think of, you know, hopefully you guys have generally some kind of C# experience. I typically will run through and try to explain everything I can. That way it always brushes up on everything and makes things clear. So hopefully, you know, kind of leave me a comment maybe saying, okay, you're dragging on. Kind of see the typical audience. Even though if you're going to be using this system, it's going to get a little hairy um, when it gets to the system of aiming and stuff, because we're going to have to move his IK hands around to actually aim at the position of the player and stuff like that when we get into the more complex part. I haven't even planned to do this just yet. So, anyway, so it's got a whole different control system entirely, and it's gonna be pretty lengthy. So, if you're getting antsy, have a cup of coffee, play a game, do whatever you guys do, chill out, go research something else that's in the same idea. If you're on a tangent about it, because I got to already thinking about what we got to do. So agent equals get component. So now that we know we have this assigned variable agent, we can use that for later. We're also we can set things in here in our initialize script. And keep in mind it's virtual, so we can always override it. So if we want to change the caps collider size of the same object with something different, like that speed variables, we can change that through code through a different object. So by overriding the method, or maybe a variable for that matter. It's all up to you. So, which we're probably going to do with the public property anyway. And then another thing we are going to do is we're going to want to grab the object of the player for our target. Later on, we'll get into writing a loop that looks for every game tag. Please search the manual for what a game tag is, because a tag just basically tabs the object globally so you can locate it, if that makes any sense. Anyway, so private game object, and we're going to call this the player for now, but later we might create a system, because let's say you have more than one player, or the AI needs to follow something different, or maybe you have helper AI. In that case, you're going to want to do a nearest target or nearest object script, which isn't the easiest thing. I can't think of how to do it in my head at the moment, because it's kind of like almost like a pathfinding system. It basically is going to calculate through all the different objects it finds with that tag and then find the closest one to it. So then it attacks the object closest to it, because it's the most dangerous typically, or you have different AI sets. And then, who knows, maybe we'll get into behavior trees or creating a behavior tree. I've not done that yet myself. A visual, like a Kismet, if you ever used Unreal or something like that, where it would be a lot easier for us to manipulate and see and change our AI. Anyway, so public game object player capital player get and set, same thing as always. Yesterday my dogs like to bark at everything. I guess that I do too. This dot player equals the value. Alright, there you go. So the player is now assigned as a variable. What we're going to want to do though is if we run this, then our player will never be found to the actual AI object. So in order to find it, we're going to say player equals our game object class. Oops, let's type twice. Find game object with tag. So this is where that tagging thing in Unity comes to be real handy. And then we're going to say dot game object. So I always use game object in my hierarchy. I don't like to use transform, even though that we're probably just going to use a transform. However, if I ever have to do anything else with the player, then I have its main game object, and I don't have to say transform.game object and go backwards forwards. Alright, anyway. Alright, so that's relatively simple. And agent dot, what is it? Steering target. I haven't used this in a while. I thought you could just drag a target over. How weird is that? Other agent settings. Huh. We should blanket that. Agent dot set destination is what we're looking for, by the way. And our target is simply just the player dot transform. So pretty basic. It'll initialize start move at us. And I think that's all we need for now. So I'm gonna hit F8 and build to make sure I don't have any compiling errors. Has some invalid, cannot convert unit transfer into a vector 3. Really? Did I do something wrong here? This dot player equals value. Wow, how strange is that? Cannot convert unity dot transform. Oh, duh! We don't want to say dot transform because transform is its transform component, and we need the positional XYZ. Oops. Alright, so this function initial is, excuse my French spelling, the agent components for our seeker type AI. Alright, that's good enough for now. So we're going to go ahead and create another C# script and call this our something like gunner, because he's going to shoot balls at us or something, I don't know. Alright, so we're going to get rid of this like always, select the typelet later. This time we're going to expose some more parameters. So in this side we're going to we're going to derive this of seeker. So now we have all the seeker methods. And we're going to write a new struct like we did before, the same, but this time it's called gunner. And say, so since we're already in hierarchy, we're using the seeker class. So how are we going to change this now? I'm going to actually change that health to be a 100. And then I'm going to change the speed to equal, I don't know, what speed does it have defaulted here? Angular speed, and we're looking for the speed. Let's just say speed is 4 for now. Maybe 2. I'm just going to set the speed to 2. Okay. And we'll pull out the damage for the hell of it. And make the damage something like 10. I know it sounds funny. I have a vaporizer. Uh, anyway, so I apologize about that. Alright, so our next step in the process is we don't need to override, like I said, at the moment anyway. We can simply type override, and we'll hit space, and it'll show us the available ones underneath the seeker class. And the only one we wrote was the initialize. We didn't write anything else. So we can always override that though. And you can see that it uses the base of our seeker class, and it exposes the things inside of that function that we can change, like acceleration, etc., etc. However, we don't need to override this, so we'll just clear that out for now. Let's get that out of the way. What we are going to do, however, is write a void, a private void here, awake. So once that object instantiates or awakes, awake, if you think about it, goes before start. So just going to keep that in mind. However, this is all case to loading too. The same thing with fix updates. A fix update, I think, goes after all the rigid bodies have been updated. So it calls after everything, all the rigid bodies been updated, and then wants to do that based on after that. That way it gives, you know, if you have something like an IK system, it's more important to say after the rigid body has done its last tick on your computer, then update that. Something in your rigid body, for example. So all we're doing is on awake, we're gonna call that initialize method now. That's all you gotta do. Yeah. And I'm gonna hit F8 and get rid of our errors there. There's some warnings, so don't mind those. Those are just things like, oh, this variable has not been used yet. Yes, it actually kind of has, in a sense. But anyway, so just attach that to our little baddie guy over here. Now he has a secret script. There's nothing exposed here yet. Um, and let's see what happens here. Hit play. Mm, mm, Whoa. Why does it not move? Hmm. Let's debug log. Let's do this. Actually, another thing to note is before we initialize, we're going to say if player of the seeker is equal to null, then we want to exit out of that method. So if there is no player inside the scene, we don't want to grab the initialize method of the seeker because we're actually finding. Oh yeah, no. I did do that really funny like. Okay. Um. Yeah, no, we don't need that. So actually, back in the secret class, we're gonna say if player over here equals null, then return. I don't know. Return the debug error log error. There is no player in the scene. Exclamation point or something. So let's see if that works. All right, there you go. A return key must not be followed by an expression. Really? Thought I could do it that way. Well, so much for what I know. Couldn't hurt to try though. Never fear. Our undo button is here, hopefully. Alright, there you go. So, if the player equals null, I'm going to do if statement. Then we're going to return that debug log error, which it should, because I don't have him tagged yet. Or maybe I do. No, I do. Is he tagged as a player? Yeah, he's tagged as a player, everybody. What could be wrong? What could be wrong? Let's say though, what I did there is if I leave him untagged, that way, uh, weird. How's it saying that we have a player? We haven't found one, because there is no player tag. I'm sorry, just making sure that the guy in our scene doesn't have a player tag somewhere. Okay. If the player, if there is no player, then we want to log error. Let's just try a regular log. Maybe I typed that wrong. Well, you can debug it later, but well then. Apparently I'm here somehow. How that is, I don't know. Let's make sure we're even in here. That puppy's so cute. Initial. God, my spelling is amazing. So, if you guys are like, what the hell is he spelling there? I'm sorry. So, I'm just gonna see. Would you look at that? Didn't initialize. Oh, yeah, that wouldn't be good. Why didn't you guys probably found that earlier? So, Kudos to you. I dragged the seeker, not the gunner, and so there's no awake method. Alright, so yeah, there we go. Now we say we initialize, and it's saying that it does not even exist. That's why that set destination didn't work, for that matter. Alright, cool. So, all we have to do is go over the player, take our tag, if you haven't made one yet, make sure that's a capital P, or whatever you named it. Hit play, and there you go. Do, do, do. Well then. There's so many different things that have changed. I don't understand why um, our guy here has stopped. I know that he stopped it like he's supposed to. Auto braking, stop distance 0. We're gonna say the stop. Actually, we're gonna go ahead and pull that stop distance, by the way, for now in the component, just to be like 5. Or maybe, yeah, 5. That way he doesn't like just run into you. Unless he's got like some kind of javelin on his nose. Alright, so once he stops, we're having an issue. Which isn't good. And the reason is because it's only initializing initial movement. So back in the Seeker class, we're going to want to do something where it updates. So for now, we're just going to call this a public virtual movement. Sometimes intelligence makes me want to switch, but it's my favorite, so I'm not going to complain. Oh, I didn't write a void. That's why. Alright, so public void movement. Again, this time we're going to say if agent is equal to null, and if player, or actually, if the agent is equal to null, or the player, one or the other, if there's none of these, and or if or, then we're going to return out of this method, and then continuously try until there is one. So, yeah. Because we want to make sure we do have an agent component attached, and we want to make sure that we have a target, otherwise this will be pointless. And then we're just going to run through and just get a million errors. Or if you build something, you always want to do that kind of stuff, because imagine if you were writing you're up all night writing 1,000 lines of code, and you know exactly what's going to happen, but you somehow make a mistake because you're tired. And then you build out a game, and then you're updating the game, an online game, and then this big old error pops up. It's not going to be a good thing. Everybody's waiting, and they waited for hours, and then all of a sudden, boop, the game doesn't work. Shit. We have 1,000 people pissed off, all simultaneously, maybe more, maybe less. 10 people. It's not good. Alright. So, all we're going to do, I'm going to make this real complicated right now, even though I kind of have ideas to make it more complicated. Set destination, like firing, or maybe cover. We'll get into cover and firing and all sorts of fun stuff. Because I need it in my game anyway, so there's no problems. And I do appreciate comments and feedback. And I'm a lonely man. Anyway. And back at our target. God, that didn't sound right. Back at our target. Oh, God. Woo! Alright, agent.setDestination, player.transform. So it's basically just recalling this method, the setDestination. So instead of it just stopping and then, especially for recalculating, because it's just going to move to the first position it saw. Uh, this one is going to continuously move to where that player position is. So it's just going to recalculate its path all the time. Instead of just saying, this is our target, this is where we go, now we stop. So you can see what you can do with pathfinding that way, seekers, and I think that's right terminology. I don't know. Alright, yeah. Oh, no, that isn't going to work. He's still going to stop because we have to go back inside the gunner. And in this one, I don't know. I don't really like the expense of doing what we're doing, but that's okay. So, we're going to say movement and just call that every time the computer updates. That way he just continuously finds where we are now. Alright, so now you can see he doesn't just stop. Boop. He wants to come see us. Um, a good little navigation system for one line of code. I mean, you gotta think of what he's actually doing here. He's actually going ahead, and if he can't see us, he's gonna move till he can see us, which is cool. Although, you know, running out like this is actually pretty complicated. If you see a lot of games, they kind of mask that with other things. So, pretty interesting. One thing I don't like though is when he does come around, so he can see us, right? But he's facing, like, where is he looking at? Like, how do you know I'm even here? Like, you're looking at me in the corner of the eye like I'm shoplifting or something. Like, what am I doing? Shh, he doesn't see me. I see you though. I have a camera behind my head. Anyway, like I'm some great notorious thief. That's okay. I'll just jump up here. Oh no, it's not marked climbable. Whoops. Anyway, to do that, layer, or excuse me, tag climbable. There you go. And then, what are you gonna do now that I'm up here? How you gonna get me? You can't. So we'll probably have him use an avoidance script. Go away, because he's like, oh shit, I can't get up there. You can climb, I cannot. I am the dumb guy, you are the character that has buttons. So therefore, my AI has to be dumb, because that's complicated. I, sorry, I'm having fun. Haha! Hey, I wonder if I can make him climbable. There we go. Tag him as climbable. I'm pretty sure I can. He's a solid object. Come here. Hit. Now what are you gonna do? I'm standing on your head. Yeah. Is he gonna move over here? Sucker. I'm on top of your head. How does that feel? Oh, that's not climbable. I gotta switch out things for climbable instead of tagging. Because what if I do want to stand on his head? Just sits there though. Just digging the headstand kind of things. Or trapeze artists. Alright. Alright, anyway, so that's fun. There you go. However, again, like I said, I don't like this. Well, it's nice to be next to you. Don't want to look at my face. You want to look at my face? Alright, anyway. So what we're going to do is in the movement. This is more complicated than it actually sounds, but it's not that bad. If I can remember. So we're going to have to create a mathematical arc. But Unity takes care of that for us. Because we're cool kids. So, what we're going to do is, the forward point of the player. So if my transformed forward equals, it ain't gonna work like that. I might have to look this one up because we need an angle. So let's see here. We're gonna make a vector 3. No, I think it's a float. Float angle to player. I think it's in the manual actually, to be honest. Um, let's look. Angle. Wow, there's too many angles. What's your angle? The fractional effect. So we're gonna say vector 3 angle. Vector angle, that'll work. Vector cup vector. I think it was a vector 3 angle. Haven't done this in a while. What in God's name? And the dogs go barking. Let's make sure we derive it. I think it is. Wow. Let's try to do this. Let's Google it like normal people do. I was gonna say something else I saw earlier, but I can't because I'm not cool. Alright, here we are. So in the manual, it describes the angle is unassigned acute angle between two vectors. This means the two possible angles between the two vectors. The result is never greater than 180. Okay, so this, I'm happy that they put this in the manual because this is pretty damn important. So over here, we're just going to copy this and replace that. Ugh. My mono is bugged. Some things that I gotta get used to. Alright, Seeker. Because we want a guy to aim at the dude, you know? It doesn't, it's just not correct. Anyway. So what we're gonna do is basically vector 3 target direction equals the target position. In our case, it's player dot transform dot position minus my position. So all this does right here is grab an angle based upon our distance, or actually it's just kind of like a distance. My position, or the target's position minus me. So I'm basically kind of like drawing a point from point A to point B. And then I want to figure out what type of angle in degrees from point A to point B is. It's so nice just to calculate this. It wouldn't be that bad in trigonometry, but however, why waste all the time? So vector 3 dot angle equals the target direction and our transform forward. So what? All right, I don't know. We can always change this. You can make it a different direction, but basically, from my forward, the forward direction, okay, this way where the gun points, we want to say from. Basically, it's just saying my position, but a step ahead. That way, we're just saying the forward direction. Or a vector 3 forward times a vector 3 plus a vector 3 forward times the amount of space of that. Alright, so our target direction to the transform forward. Now, if our angle is less than 5 degrees of the player position, so if our player is right here, okay, then this is void. But if our player is about like right there, maybe somewhere, it draws this arc right here. So if our player is inside a 5-degree arc of our forward, then, you know, it is visible. So this isn't what we want though, because we want him to rotate towards them. Although, keep that in mind. So if we are greater, well, Alright, before we do this as well, since uh, well, if agent is stopped, apologize. So if the agent is not stopped, return, back out. Stop! So if the agent is not, if the agent does not, well, if the agent has not stopped, we don't want to do this. But if the agent has stopped, we're going to follow through with this method. And basically what we're going to do is rotate towards the player if we're not inside the angle. So the next thing we're going to say is if the angle is greater than, we're going to go with 10. Actually, we're going to go with 5. And if the angle is less than 5, actually, sorry, we're going to back out. And if it is greater than 10 and we can't see them, then we're going to want to rotate towards them. So we're going to do something simple because I got to cut out here. Quaternion dot quaternion quaternion look. I apologize. Quaternion look direction equals quaternion dot look rotation is the player dot transform dot position. Alright. And then we're going to say look, we're going to do something simple here and just kind of clamp out look direction dot dot y equals 0 and look direction dot x equals 0 for now. Not y, excuse me, z. And then we're going to go ahead and say transform dot rotation equals the look direction dot equals look direction. I hope I did that right. Alright. I think it's backwards. Because if you see we walk around. That's interesting. Quaternion look direction equals quaternion look. No. Player transform position minus my transform dot position.
Guys, fuck.
No, we'll get into this a little later. I'll cut it short for now. When I have a little more time. Alright, so hopefully we'll see you later.